Hello everyone, my name is Vivek. I am a software developer. I make videos about containers, Kubernetes, Go as a programming language, and sometimes about software engineering in general. If you have been liking the videos that I've been making, you should consider subscribing to the channel and maybe sharing it with your friends, colleagues, and classmates. In this particular video, we are going to look into what are Kubernetes volumes or persistent volumes, why do we actually need them, and why how can we provision one. So we are not actually going to look into the differences between different kinds of volume types, but we are going to focus into how we can provision a volume if we want to, and how that provisioned volume is actually bound to a workload that is running. So for example, if you have an application that requires some volume, how that volume is going to get provisioned, and then if the volume has been provisioned, how we can attach or bound that volume to the running workload. So I already have a Kubernetes cluster up and running, one node kind cluster. So let's just go ahead and first try to understand the use cases in which we would actually want to use Kubernetes volumes. So for example, let's just assume we have a pod up and running, and in this particular pod, let's assume we have two containers that are running. So this is container one, and this is container two. So let's name it C1 and this to be C2. So there are chances, for example, let's say there is a file that needs to be shared between these two containers. So for example, let's say this is main application container, this is supporting container, let's assume, and there is a specific file, there is some data that needs to be shared between these two containers. So this is very simple and very first use case that is coming into my mind. And in this particular case, what we can do is we can actually provision a volume, let's say. So let's assume we provisioned a volume. Now it totally depends on the provisioner how this particular volume is provisioned. For example, this particular volume can be inside or can reside inside the cluster itself, or it can be outside of the cluster as well. We are going to look into those things in a bit. So for example, let's just assume that a volume has been provisioned, and after this volume has been provisioned, now both of these containers can actually talk to this particular volume, and this is what was required in our case. So this is very simple and naive example, I would say. Another example would be, for example, let's assume you want to run some database on your Kubernetes cluster. So let's say this is your MySQL database, and this MySQL database, if we are trying to run this MySQL database on top of Kubernetes, this database would require a volume where it can store the data. So in this particular case, again, we will have to provision a volume, let's assume, and this particular volume would be used to store everything that is being dealt with using MySQL. Now, once we have this volume provisioned, we can actually mount this volume onto this application or workload at a specified path. So, for example, we know that MySQL tries to store. Let's assume MySQL tries to store the data at path var lib and data. In that case, what we would do is we would create a volume, and then that volume would be mounted on the workload or on the pod at this particular location. And now if MySQL tries to store anything at this particular location, all this data would be eventually stored into this volume, because this particular path or this particular volume is mounted on this specified path. So yeah, I mean, these are some of the use cases because of which we would want to use volumes in case of Kubernetes. Now For example, let's just assume that we depending on the use cases, we would want the volume to be present for the entire time, for the eternity, let's say. And in some of the use cases, we would want to get rid of that volume after some time. So for example, if we talk about this first use case, if we just have to share a file between these two containers, maybe we can use a volume that is not persistent, that is ephemeral. And as soon as this particular pod is destroyed, this particular volume would also be destroyed. So this kind of volume is called as ephemeral volume, or that volume is not actually persistent, because as soon as the pod is destroyed, the volume is also destroyed. The other kind, or the other other way we use the volume is the persistent volumes. So for example, if we talk about the second use case, in this particular case we are running MySQL database and we are trying to store the data into this particular volume, but we would not actually want this volume to be destroyed as soon as this workload or this pod is deleted. And the reason is, we would want to persist the data that has been stored into this MySQL instance. That data might contain some useful information. So this is the kind, or this is the use case where we would actually want to use persistent volumes. So now that we actually have a basic understanding of what are ephemeral volumes, what are persistent volumes. Now what we should do is, we should actually go ahead and try to look into how we can actually provision the volumes. So even if we talk about ephemeral or persistent volumes, the things are going to be almost same, but rest of the discussion is going to be more focused into persistent volumes. So there are two ways to actually provision a volume. One way is to we call it static provisioning, and the other way is dynamic provisioning. So in case of static provisioning, what we do is, for example, we know that our application is going to need 10 gigs of volume. So in that case, what we try to do is, we provision the volume first. So let's say we have provisioned the volume, and then what we do is, we actually run a pod. So let's assume this is the pod that requires 10 gigs of disk. So in that case, what we do is, or what cluster administrators do is, they provision volume. So for example, they provision this volume for of 10 gigs, and then they configure this pod to use this particular volume. Now there is this another concept of claims that is actually used to bind a workload to a volume, and that we are going to look into in a bit. So yeah, I mean, there are a lot of ways using which a cluster administrator can provision a volume, and we are going to look into those types in a bit. But yeah, if we talk about on very high level, let's just assume cluster administrator has provisioned a volume of capacity 10 gigs, and if a pod requires, or if a pod needs storage of 10 gigs, in that case, pod can ask, or pod can use claims to use this volume. So this is static provisioning, because we already have, or cluster administrator has already provisioned the volume that is going to be used by the workload. The other way that we normally use is dynamic provisioning. So in that case, what we do is, let's say we have our pod, and this pod requires 5 gigs of disk. In that case, what we do is, we create a claim, And in this particular claim, we specify that this particular workload or this particular claim needs 5 gigs of disk. So in that case, uh, depending on the configuration, depending on the settings, a volume of 5 GBs would dynamically be provisioned, and then this particular volume would be bound to the claim that requested this volume. So these are two ways using which we can provision the volumes. Now let's just assume that we have some volumes available on the cluster, and then we are requesting, or the claim is requesting, for a specified number of storage. So for example, let's say we have these 3 volumes available for this much storage. Now let's just assume that we have a workload that requires, this is MySQL database, and this requires 6 GBs of disk. So in that case, we can see that even though we have 15 GBs available in the cluster, but this particular instance needs, or this particular application needs 6 GBs of volume. We are not actually, this particular request is not going to be fulfilled, because as long as these volumes are available as three separate resources, 3 separate entities of 5 gigs each, they are not going to satisfy a request or a claim of 6 GBs. So this is one thing that we should take care of. Now let's discuss about, if we have a request, if we have a claim for specified amount of storage, and there are some volumes available, how does that claim match the volumes that are available? So for example, let's assume we don't actually want 6 GBs, we just want 4 GBs of disk. So in that case, what happens is, again we are talking about static provisioning. So what happens is, Kubernetes actually looks into all the volumes that are already available in the cluster, and then it actually matches the resource or storage requirement and the access mode. So these are two things that are actually matched. So for example, storage requirement, and the other thing is access mode. So we are going to look into the access mode in just a bit, but storage requirement just means the amount of storage that the claim is requesting. So in that case, this particular claim is requesting 4 GBs, and all of these 3 volumes satisfy that. Now if we talk about access mode is actually, or access mode actually specifies the way clients are going to use this particular volume. So again, let me rephrase that. So access mode is a field that actually specifies how many clients can access or can read write a specified volume. So there are some values for access mode that are supported. One is read write many, another one is read, let me look into the notes that I have, read write many, read only many, and the third one is read write only. So it simply means, now if we talk about these access mode, so the access mode read write many simply means that this particular volume can be used by multiple workloads for read and write purposes. So RW simply means read and write, and X means multiple clients or multiple workloads. So RWX means this particular if a particular volume has access mode RWX or read write many, that simply means that the volume can be used by multiple clients for read and write purposes. Similarly, if we talk about read only many, it simply means that if a volume has this particular access mode, that particular that particular volume can be used by many clients, many workload, just for read purposes. So it simply says read only. So it means this particular volume, or a volume that has this particular access mode, can be used by many clients, many workloads, for read only purposes. And similarly, as the name suggests, if we talk about read write only, it simply means that this particular volume, or the volume that has this particular access mode, can be used only one workload, or by only one client, for read and write purposes. So again, when I say can be used by clients, I actually mean can be mounted on workloads. So if I talk about read write many, it simply means that if a volume is provisioned using this access mode, that particular volume can be mounted on several workloads for read and write purposes. So yeah, I think that makes sense. Now that we know what are access modes, when we request for a particular volume, what there are two things that we specify. There are basically two things that we specify. First one is storage, and the other one is access mode. So for example, let's say we have three volumes, and this one is provisioned using RWX, this is ROX, and this is RWO. And the access mode that we requested in the claim or the request is, let's say, read only many. In this particular case, let's say this is a request that we have specified, and this particular request is going to be bound to this particular volume. So this is how a claim matches the volumes that are available on the cluster. And yeah, now we have a very basic understanding of how a claim is matched with a volume that is already provisioned. Now let's just discuss in very short which particular component is actually responsible to do this. So in one of the very first videos, we looked into this component of Kubernetes, that is Kube Controller Manager. And there is a controller that runs inside Kube Controller Manager that actually looks into this claim resource. So as soon as we create this claim resource, that controller that runs in Kube Controller Manager looks into this particular claim and then tries to bound it to a particular volume. Now again, there are chances that the volume is already available, and if the volume is already not available, then that controller, let's call that persistent volume controller, actually tries to provision a volume and then bound that volume to this particular request or claim. So let's just go ahead and try to have a very brief look into that controller. So let's just get all the pods from Cube system namespace, because we know that all the core components are deployed on Cube system namespace. So edit pod from Cube system namespace with name controller manager. So if we actually try to look into the command that runs, we can see that on line number 243, we can see that it actually runs all the controllers by default, and asterisk simply means all the controllers are running by default. Now if we want to look into all the controllers that are available, what we can do is, let's just go ahead and try to exec into the pod that is in Cube system namespace named Cube Controller Manager. And if I okay, so it looks like we don't have it's not a problem, I think. The other way we can actually try to figure out what are all the controllers that are available. We can actually go to the Kubernetes source code, and we can look into this source file named controller.go, and this particular source file actually registers all the controllers. Just give me a second. Alright, so as we can see, these are some of the controllers that actually run when we specify asterisk in the kube controller manager. So if we can see here, we do see persistent volume binder here, and this is the controller that actually gets to do all the things when we try to run, or when we try to create a claim in our Kubernetes cluster. So yeah, I mean, the controller that we just saw actually listens on, or actually looks for the persistent volume claims, or request in very naive terms, and then it actually tries to figure out if there is any other volume that is already created, and that satisfies the requirements that are specified in the claim. And once that request is met, what happens is controller actually updates this particular volume. So let's assume this is the volume that was matched. So this volume's spec or specification is modified to have the claim reference of this particular claim. So this is the first step that happens. First, this volumes spec field is updated, and once volumes spec field is updated, then the claims spec field is updated to actually specify the volume that it is bound to. So this is how this binding happens. Now the other thing that I would like to talk about is, let's assume let's assume we want to provision the volumes dynamically. So first of all, we will have to specify in the API server that we want to enable dynamic provisioning of volumes in this particular cluster, and that can be done using Cube API server, and we'll have to specify a specific value for a field in the Cube API server. I think it's named enable admission plugins, and in that for that flag we'll have to specify uh, that we want to enable dynamic provisioning on this particular cluster. So yeah, I mean, now that we have a pretty good understanding of how a claim is actually bound to a particular volume, now let's just go ahead and try to have a better look at the workflow of how things are actually working. So for example, let's say we have this particular workload, and this workload requires a volume of, let's assume 6 GBs. And in this particular request or claim, we call it PVC or persistent volume claim. In this claim we specify the request, let's say 6 GBs, and then we also specify access mode as we discussed already. So let's say we have specified read write many. Now there is this another object or another Kubernetes resource that is actually used to provision the volumes dynamically, named storage class. So optionally this particular claim can specify a value for storage class. So for example, if this particular volume specifies a value of storage class to be something, let's say standard. In that case, what happens is, first of all, PVC controller or persistent volume controller would as soon as this PVC is created, persistent volume controller would look into this persistent volume claim, and then it would first try to figure out if there are any available volumes in the cluster that match this particular requirement. Now if the volume is already provisioned, in that case, as we have already discussed, for example this volume is matching, in that case spec field of this particular volume would be updated to refer that this particular volume is bound to this particular claim. But if the volume is not found, in that case what happens is, the provisioner of the storage class that we have specified, so for example we have specified storage class to be standard. In that case provisioner for that particular storage class is actually used to provision a volume. So let's assume this volume was not actually present. In that case, provisioner for this particular storage class is used to provision a volume. Let's say this new volume 2 was provisioned. Now what controller does is, it actually figures out if this particular volume should be bound to the PVC immediately or not. So in some cases there are chances that we just created a PVC request. So we just created a PVC request for a specific volume, and we have specified a storage class to be standard. In that case, using standard storage class, this particular volume was provisioned. But there is this another thing that controller waits for before actually attaching this volume to this particular claim, and that is volume binding mode. So there are two volume binding modes that I can think of, or that I can remember as of now. First one is wait for first consumer, I think, and the another one is immediate. So what happens is, in the case of wait for first consumer or wait for consumer, this particular volume would not actually be bound to this particular claim until and unless there is a workload that is requesting this volume using this PVC. So if we just create a PVC and the volume binding mode is wait for first consumer, in that case, if we just create a PVC and a workload is actually not requesting any volume using this PVC, this volume would not actually be mounted to this, or would not be bound to this PVC until and unless there is a workload requesting this PVC. Another volume binding mode that we see here is immediate, and immediate simply means as soon as we create the PVC, if we can, or if controller can provision a volume using the provisioner that is specified in the storage class, in that case, as soon as the volume is created, that volume would be bound to the PVC. So volumes spec field would be updated, and then in turn PVC's spec field would be updated to refer the volume. So yeah, this is another thing that I just wanted to talk about, that is volume binding modes. Now if we talk about the storage class provisioners, so for example let's say we have a PVC resource. So this is PVC resource and we have specified the storage class to be X. In that case, what happens is, let's say this is the controller code. This is the controller code. So what it does is it actually calls provisioner for this particular specified storage class. So for example, let's say this controller calls provision method on specified storage classes provisioner. So based on the volume that we are using, for example, let's say if we are trying to provision an AWS EBS volume, in that case what would happen is, let's say this is AWS EBS volume code that we have in Kubernetes repository. Similarly, let's say we have another, or let's say GCE PD provisioner. These are provisioner code that are already there in the Kubernetes code base. So for example, controller looks into the storage class provisioner. So when we specify or when we create storage class, we actually specify provisioner as well. Again, we are going to have a look into that in a bit. So for example, this storage class is created. Controller actually looks into the provision for storage class, and we specify storage class in PVC. So in PVC we specify this storage class, and as soon as this PVC is created, controller gets that PVC or claim and then figures out the provisioner that is there in the storage class, and then calls this respective provisioner's provision method to actually provision the volume, and then bind that volume to the PVC. So did I make sense? Let me explain that once again. So the persistent volume controller that is already running, that figures out the provisioner from the storage class and then calls the respective implementation. So there are other volumes as well that we are going to look into in just a bit. For example, let's assume host path, and let's assume Cinder or GlusterFS. So based on the storage class, controller calls the respective provision method of these provisioners and then provisions a volume, and then the same thing happens. Controller changes the volume spec field to specify which particular PVC that volume is bound to, and then eventually updates the PVC to actually specify which particular volume it is bound to. So yeah, I mean, now I think we have a pretty good understanding of how things are being provisioned and how storage class can be used for dynamic provisioning. Now let's just go ahead and try to have a look into the code base for a second. So for example, this is the PV controller that we were talking about. So this is the main method that we are going to look into. So we can see here, let's assume sync claim is called when that controller runs. So when sync claim is called, we actually figure out if the volume or if the claim has already been bound. So we check that using an annotation in the PVC. So what we are saying is, if claim has this particular annotation, and this annotation is pv.kubernetes.io bind completed. So as soon as a claim has a volume bound to it, in that case the claim would have this particular annotation, and that is what we are checking here. So we are checking if claim has this particular annotation. It simply means that the claim already has a volume. So in that case, this particular flow would be called. But if this condition is not true, in that case we are calling sync unbound claim, and if this simply means PVC is in pending state. We can see here. So we can see that the PVC is in pending state, and we are not actually specifying, or we have not specified any volume name in the claim. So this particular flow would be called, and as we discussed in one of the previous diagrams, we first try to figure out if there are any other if there are any volumes that are already created that match this claim request. So this is what's happening here. If you see here, find best match for claim, so it just tries to match best volume that is available for that particular claim. And if volume is not found in that particular case, we actually try to provision a volume using this particular method, as you can see here. So provision claim is called, and in this particular provision claim we actually try to figure out if the operation is internal or external. And let's assume it's internal. In that case, provision claim operation is called, and then here we actually try to specify, we actually try to first figure out the storage class, if you can see here, claim class, and then we also figure out the provisioner, and then we actually call the provision method of that provisioner. So if we just go here, we can see here provision method of provisioner is called, and this is the provisioner that we specify in the storage class. Now let's just go ahead and try to relate the exact same thing that we are looking into by host path provisioner. So if we look into the host path provisioner here, this is the provisioner that should be used in the case of host path. So I already have a definition for storage class, so let's name it host path, and provisioner is going to be kubernetes.io host path. Now, so if we talk about this particular storage class, if we create this storage class and then we create a claim using this particular storage class, when we call provision from the PV controller, this particular files provision method would be called. So if we look into this, so this particular method would be called, I think I'm going into very much detail, but yeah, if you are not understanding something, just maybe let me know in the comments. We can discuss about that in the comments as well. So yeah, now let's just go ahead and try to create the storage class. So let's just first list all the storage classes from the cluster, and we should be able to see one storage class that gets deployed when we deploy a kind cluster. And if we create this storage class, we should be able to see another storage class that has been created, and we can see the volume binding mode for this particular storage class is immediate, but the other one is wait for first consumer, and we have already discussed about them. So now let's just go ahead and try to look into the PVC that we have. Let's assume this PVC requests storage for 2 gigs, and access mode is read write many. I just want to show you something, that's why I have specified the access mode to be read write many. Now if I just go ahead and try to create the PVC, now again let me explain what is going to happen. As soon as I create the PVC, persistent volume controller would actually try to figure out if there are volumes already created in the cluster that match this particular request. And if that volume is already not created, in that case storage classes provisioner is going to be used to actually provision the volume, and then that volume is bound to the PVC, and then PVC's spec field is updated to refer the volume. So let's just go ahead and create the PVC in the default namespace, and so we didn't specify the name, that's why we saw that issue. So it says that the claim has successfully been created, and if we list all the PVCs from default namespace, we can see that this particular PVC has not been bound. And to figure out why what exactly the reason is, what we will have to do is we'll have to actually describe this particular PVC. So if we describe this PVC, it says that waiting for first consumer to be created before binding. Now I think we have made a mistake here. Okay, this should not actually happen because we have specified. Okay, so storage class is being used, that is being used here is standard, and we don't actually want to use standard, we want to use host path. So what we are going to do is, in the PVC we are going to say storage class. Again, another thing that I wanted to discuss about is, if we leave the storage class field empty, in that case the default storage class of the system is used. So the default storage class of the system is standard, and that's why for this particular PVC standard was used. So let's just go ahead and try to delete this PVC, and in the PVC definition what we are going to do is we are going to specify the host path storage class. If I create this PVC once again, we can see that the PVC has been created and it has actually been bound to this particular volume. So we did not actually create this volume. So if we get all the volumes, we did not create this volume. This volume was created dynamically when we used that storage class. So yeah, I mean, yeah, this was pretty much it, what I wanted to discuss about volumes. And if you want to, if you want me to have or give a walkthrough of this particular code, maybe I would like to do that as well. And like we saw for host path, we can see other implementations as well. So for example, we can see here AWS EBS, and in that case the plugin or provisioner that we are going to specify in storage class is kubernetes.io AWS EBS, and similarly GCE PD. And if we look into this particular package, we can see all these all these volume types here. So GlusterFS, GCEPD, Flocker, Flex, and things like that. So yeah, I mean, the other thing that I wanted to discuss about is this particular provisioner that we use in storage class. So if we look into the storage class that we created, we specified provisioner, and the controller figures out if the provisioner is internal or external by looking at this particular value. So if this particular value has kubernetes.io in it, in this particular case controller figures out the provisioner should be internal, otherwise external. So let me explain that one more time. So when a claim is created, controller actually looks into all the looks if there are any volumes that are already available and that match the claim request. If that doesn't happen, in that case controller figures out the provisioner, and once provisioner is figured out, controller actually figures out if this provisioner is internal or external, and that logic is implemented using this value. So if this value has kubernetes.io in it, in that particular case it simply means we are using internal provisioner, otherwise external provisioner. So let me try to maybe show that to you as well. So in this particular file we should have somewhere this check. So we can see here, if provisioner has this particular prefix, in that case we actually use internal, or in other case we specify that the provisioner is external. So yeah, I mean, this was pretty much it about what I wanted to talk about volumes. And in Kubernetes, if you missed something, yeah, I just looked at my notes and there is something else that I forgot to discuss. So for example, let's say we have a volume provisioned, workload used the volume, and then let's assume workload has been deleted. So in that case, let's assume we had this workload, and this workload was actually bound to this volume using a specific claim. So so reclaiming, so when we delete this particular workload, let's assume in that case, in a way this particular volume is not being used by any workload. So reclaim policies actually specify what should happen once this particular workload has been deleted. So there are three reclaim policies that we have as of now. One is retain, another one is delete, and third one is recycle. So in case of retain, what happens is, even though this particular workload is deleted, the volume that was provisioned would be there, and there are chances that this volume actually provisioned the storage using the storage provider, for example AWS, EBS. So in the case of retain, this particular volume resource in the Kubernetes would not be deleted, and neither the storage that was provisioned in actual storage provider. So that is what we mean when we say retain reclaim policy. So, and this particular volume would be marked as available, but this would not be used by any other claim. So for example, if another claim tries to request this particular volume, in the case of retain, this particular volume would not be mounted or would not be used by this particular claim. And the reason is, the data from the previous claim would already be there, and if we try to mount another workload on this particular volume, things are not going to work as expected. So this is the reason, even though this particular volume is made available, it would not be used by any other claim. Another reclaim policy is delete. So in that particular case, the as soon as the workload is deleted, the volume would also be deleted. And in the third case that we have, that is recycle, in that particular case, the volume is actually the things from the volume are actually erased, and then if another, let's assume another claim tries to access or tries to request this volume, this particular volume would be mounted or would be bound to this particular claim in case of recycle. Again, not all the provisioners support all the reclaim policies. So this totally depends on the provisioner that we are using. So yeah, I mean, this was pretty much it. If we talk about recycle, before making this volume available for another claim, all the data, I think I mentioned that all the data from this volume is actually erased. So yeah, this was pretty much it. If you liked this video, you should consider subscribing to the channel, leave comments about any questions that you have, and yeah, that was pretty much it. I'll see you in the next one. Thank you.